Hello class, today we are going to be rationalizing the denominator. And the reason we're rationalizing is because for an expression to be simplified, we cannot have a radical in the denominator. So right now this almost looks like it's fine except for the square root of 5 is located in the denominator. So we are going to get it out. You should remember this from Algebra 1 and especially geometry when you did special right triangles. So if you recall, in order to get anything out of the denominator, if you remember the theory about the square root of 3 times square root of 3 equals 3, and you remember the square root of 4 times square root of 4 would be 4. If you can remember this, the square root of anything times the square root of anything gives you that value. So, for example, if I multiply this denominator by the square root of 5, square root of 5 times square root of 5 is the square root of 25, but I don't want you to write that in the denominator because we're trying to get rid of a radical. So what I prefer in the denominator is that you realize it's the square root of 25 and you put a 5. But whatever you do to a denominator of a fraction, you must do to the numerator. So therefore, 2 root 5 would go here. And if you can't simplify any more, then that is your final answer. So 2 square root of 5 over 5 is our final answer. If I look at problem 2, you should kind of realize it's not much different except for there's a 2 in front of the root 5. And I want to let you know that you don't really need to deal with the 2. It is okay to have a number in the denominator, just not a radical. And 2 root 5 is not a group. So if I simply just multiply by the square root of 5 again to get rid of this and the square root of 5 up here, I will get 2 times, and remember this would be the square root of 25, but I'm going to try not to write a radical in my final answer. So square root of 25, which is 5, but because there was a 2 down there, it's 2 times 5, which is 10. On the top, it would be square root of 6 times square root of 5, which is square root of 30, and then that is basically a great answer. You should check if square root of 30, because it's a radical, and you now multiplied to get there, that if it could be broken down. But 6 and 5, 3 and 2, there's no pairs, so 30 doesn't break down, and the square root of 30 over 10 is our answer. If you happen to multiply by the 2, it would have been fine if you included it, so 2 root 5 and 2 root 5, you would have up top got 2 root 30, all right, you can't forget the 5 and the 2. And on the bottom, you would have got 2 times 2, which is 4. Square root of 25, square root of 25 is 5 times 4, so you would have got 20 on the bottom. And then you would have had to realize that 2 over 20 simplifies to 1/10, a 10 on the bottom. So it doesn't matter if you brought the 2 with it, but I just want you to realize you don't have to if there's not a plus or minus between it. So why don't you try the next 2, pause the video, and try the next 2 on your own, and I'm just going to put up the answers in a second. So go ahead, pause. Since you should have paused and done this first, I'm going to do it very fast. So I'm going to get 3 root 15 on top. I'm going to get 5 on the bottom. 15 can't break down, so you're done. Down here, I'm only going to do the root 3. I'm going to get 4 root 3 over 2 times 3, which is 6. That's a great answer, except 4 over 6 simplifies to 2 over 3. Okay? Now let's look at our example. You should notice that this is a little different, and the reason it's a little different is because it is now a group in the denominator. And so this is the only thing that's really new. That last part's not new to you. So all I need you to realize, in order to get rid of a group, when I multiply, I need the middles to come out. So if you realize that when we FOIL, I need the middle terms to come out. So I can do that by multiplying this group by what we call its conjugate, which is the exact same group, except the signs are different. So for example, I would get 2 times 2 is 4, because I have to FOIL. I'm going to get minus 2 root 3 when I do that. In here, I'm going to get a positive 2 root 3. Now, if you see these middle terms are not different signs, they're not going to go away. And then I get root 3 times root 3 is root 9, which is minus 3, because the square root of 9 is 3. And now this and this will clear out, and 4 minus 3 is 1. Now, since this fraction is 1 over 1, it's fine to say my answer is, oh, I'm sorry. So that, yes, so whatever you do to the bottom, though, we now have to do to the top. So now I have to take 1 times 2 minus the square root of 3. So I'm going to now do 1 times 2 is 2, and minus square root of 3, and I got 4 minus 3 on the bottom's 1, so 2 minus the square root of 3 is fine for my answer. So why don't you go ahead and try this one. Remember, it's going to be exact. Why don't you pause it? After I do this, it's going to be exactly the same thing. So you're going to put that down here. That's its conjugate. It's exactly the same thing, but different signs. You're going to FOIL 1 times 1, 1 times root 6. Then in here's plus root 6. And root 6 times root 6 with a minus sign is 6. These will cancel, leaving me 1 minus 6, which is negative 5. So it's okay to have a negative. Whatever I do to the bottom, I must do to the top. So 4 times 1 is 4, minus 4 root 6. Okay? I cannot simplify that top. That top's a group. It could only cancel if there was another 4 minus 4 root 6 on the bottom. So you're done. I'm going to stop there. If you'd like to try number 7 on the note sheet, that'd be great. I'm just going to set it up, but I'm not going to do it. All you need to do is put a minus sign, and it will work because the middle terms will still cancel out. But whatever you do to the bottom, you must do to the top of the fraction. And so, sorry, it should be a 2. And so go ahead and try that problem. We'll come back together on that. Thanks.